Hello and welcome back. I'd like to do number 2 here. This is week number 1 of our prep for the IB exam. So let's get it started, as they say. Okay, so here we got a problem. Likely paper 1, maybe paper 2. Solve the following inequality. And typically what I like to do with inequalities, especially inequalities that come out to be quadratics, right? There's a quadratic. What I like to do is first think about where these are equal and then work backwards to the inequality itself. And at the end, we're going to graph the quadratic and then isolate portions of the function that are less than, it looks like, or lower than the x-axis. So I'm going to do a quick substitution to make this a tad easier. So I'm going to take u and set it equal to ln of x. In the process, what you'll see is something a little bit nicer show up. So this would be u squared minus ln of 2u. And I'm going to subtract that 2 ln of 2 squared over. It'll be minus 2 ln of 2 squared equal to 0. So now it looks like something potentially that we could factor, and in fact, we can. So I'm going to factor this. I would have linear factors of u and u, where the first factor would be u plus ln of 2, and the second would be minus 2 ln of 2. So if you're to FOIL that out, you can do a quick check on that, pause the video if you'd like, but that's what it would come out to be. So I'm going to solve here, setting each of these using the zero, oh, that was weird, the zero product property, which says if the product of two items is 0, then one or the other has to equal 0. So if the first equals 0, then u would have to equal ln of 2. Oops, sorry, negative ln of 2. And if the second is, then u would have to equal, oh my goodness, this is glitching on me, 2 ln of 2. All right, so what was u? U was ln of x. So if ln of x equals negative ln of 2, I have to get this in the same form. So the second natural log on the right side of the equation has to be positive, and I can bring that negative up into the exponent of the argument. Therefore, ln of x is equal to ln of 2 to the negative 1, which is 1/2. So it looks like this function is equal to 0 when x equals 1/2. My goodness, stop please. There we go. And on the other side, similarly, oops, I didn't want a u there. ln of x is equal to, bring that 2 up there, it'll be 2 to the second, so ln of 4. Looks like this is also true then at x equals 4. Now, where do we go from there? Because we want to know where this this thing, right? Where is ln of x squared minus ln of 2 ln of x less than 2 ln of 2 squared. So where is that true? Well, I know it equals this. So this is equal at these values, okay? If you were to look at this takes on the form of a quadratic, right? If I circle these are my u values. It takes on the form of a quadratic, so I can sketch it. And it equals at positive 1/2 for x and at positive 4 for x. Since the coefficient right here of the leading term is positive, the graph should open up. It's my dog whining in the background. Therefore, this is the portion of the graph that would represent the inequality that we are looking at. Therefore, our answer, this is true when x is between 1/2 and 4. You could use different notation for that if you'd like, saying, you know, this interval notation, 1/2 to 4. Either one is acceptable. I think IB sometimes uses these weird Australian, I don't know what they are, brackets. This is not inclusive. So any one of those three right there is acceptable, and that's number 2. All right. Let me know if you got questions. Otherwise, we're good to go.